So you might notice on the screen that it says Unit 1, Lesson 5. That has to code with your textbook. But we are going to be on our game board piece, and on our game board piece we're on Lesson 3. So this part of the book starts you out with Engage Your Brain. We're going to be talking about the phases of matter. In what ways does matter exist here on Earth? So you start out on page 77 with a fill in the blank. And remember, the Engage Your Brain is to see what you know right now. So it's okay if you have a wrong answer. When you're finished with this unit, you can come back and look at your answers and say, oh, I can see why I got that wrong. Next, it wants you to unscramble a set of words. And then you start with your reading. And so the first section is called Particles in Motion. And we're going to be working on the standard that has us investigating how particles move in solids, liquids, and gases. The kinetic theory of matter states that all matter is made of small particles. We now know that those are atoms that are in random motion and that have space between them. So this is a graphic organizer that's going to encompass what we're going to be going over for the next couple of slide sets. So we have solids on the left, liquids, gases, and then plasma, the 4 states of matter. So we're going to start out talking about a solid. So solids are described as having a definite shape and a definite volume, meaning that they're not going to flow like a liquid does. The particles are packed in very close together, but remember, they still have some space between them. We might be able to see it, but it's there. The particles aren't able to move around freely because they're so closely packed together. And atoms vibrate, and this has to do with the position of the electrons and the protons in the nucleus of the atom, but they are in constant motion. So they're kind of doing like a wiggling in place. On page 5, you have a describe question, and the describe question wants you to think about how are the particles in a solid like people sitting in a movie theater. So pause the video, answer your question, and then come back when you're ready. The next phase of matter is a liquid. In a liquid, the particles are vibrating, but they're vibrating faster than a solid, and they are able to slide past one another. So they have a definite volume, but they don't have a definite shape because they're going to take the shape of the container that you put them in. So if you have a round bowl and pour water in it, the water is going to have a definite volume, but it's going to take the shape of the bowl. If you take that same amount of water and pour it into a cylinder, instead of being in the bowl, it's going to change to the shape of the cylinder. But it'll be the same volume of water. So, things to remember about a liquid. They have a definite volume, but not a definite shape. And if we were to correlate that with what is a solid has a definite shape and a definite volume. On page 79, you have question number 6, which is going to have you describe. And it's going to be back to the movie theater analogy. Now it's asking you to describe how the particles in a liquid are like the people in a movie theater lobby. So pause the video, answer your question, and then come back when you're ready. The next state of matter are gases. Gases are moving very quickly. They have a lot of kinetic energy, and they escape from having to slide past each other, and they escape into the gas form. Gases do not have a definite volume, and they do not have a definite shape. So remember, when you're comparing these three states, that you're going to talk about whether it has a definite shape or a definite volume. Number 7 on page 79 again wants you to describe, and they want you to describe how the particles in a gas are like the people outside of the movie theater. So if the movie theater is in a mall, what is it like outside of that movie theater library? Answer your question, pause the video, and come back when you're ready. The next state of matter is plasma. Plasma doesn't have a definite shape or a definite volume, and it's different than a gas in that it has electrical charges. One of those things that we're going to look at are electrons. And if you remember, electrons are the negative part of an atom. So a plasma has free-floating electrons. Where could we find plasma? We can find that in very hot flames, in lightning, in the sun, and the aurora borealis, or the northern lights. There's also southern aurora. Something that we need to talk about is that with things heating up, we get what's called thermal expansion. And this is the increase of size of a substance when the temperature is increased. Now, we might not be able to see that increase with our eyeballs, but microscopically there is an increase that's going to happen. So in a thermometer, what happens is the liquid in the thermometer, the molecules gain more energy. And so with that energy, they spread out. They bump into each other and cause the molecules to spread out, and that pushes the liquid up into the thermometer. Thermal expansion can cause us a lot of headaches. It can cause sidewalks to crack, and it can cause pavement to crack. So when the pavement gets hot, and it gets hot enough, it can expand enough that cracks form or breaks within the asphalt or the concrete in the sidewalk form. Thermal expansion happens when things heat up, and this happens with a hot air balloon. The hot air gets blown into the hot air balloon, and those gas molecules are moving more quickly than the cold gas molecules outside of the balloon. So this causes the air in the balloon to expand, and the balloon starts to float.